Okay, the next thing we're going to do is you have a sheet that looks like it did yesterday, but now we're going to look at this. Chad, Martha, Thomas, Enrique are in class. How many possible two-person teams can be created from this group? Now, we're not ranking these. So when I put Chad, Martha, I don't put Martha, Chad, because that's the same group. I don't need to reorder the group. Chad, Thomas, Chad, Enrique. Now, that's just groups with Chad in them. So Martha, Thomas, Martha, Enrique, and then Thomas and Enrique. That ends up being 6. Now, the way to solve this, you're not really ranking them first, second. You're just taking them in a group. You'd use what's known as a combination. Combination, instead of a P, you make a big C. You put how many you have. You have 4 people, and you're putting 2 in a group, so there'd be 2 left out of the group. Now, in combinations, in the expression, we use all of them. We don't cross any of them out. So I put 4 factorial, and both these 2 with their factorials go on bottom. So I number a 4 down till I'm at 2, okay? And then the 2's can cancel, but then there's this other 2 here. That's 2 times 1, okay? So 4 times 3 is 12, 2 times 1 is 2, and that's going to be 12 divided by 2, which is 6. Okay, now, going to be happy we have that here. So I've got 15 people. I want to know how many combinations, how many combinations of groups of a group of 3 I could create. So there'd be 12 left out of the group, but I don't really want anybody ranked, so I need to, on my line, I need to put both the 12 that are left out and the 3, because I don't want those 3 to be ranked first, second, third. I don't want it to find all the When I take a group of 3, I don't want to find all the orders first, second, third, just a group of 3. So that's why it goes on bottom, so it can be divided and factored out. So I number the 15 down to probably 12. Go to your higher number. And then the higher factorial is canceled, but this is still 3 times 2 times 1. So I wrap these up. I like to put them in parentheses so I can go to my calculator. Parentheses 15 times 14 times 13, and then close the parentheses, divided by parentheses 3 times 2 times 1. Close it. 455 possible combinations. Okay, I've got 16 people. I need a team of 4. I want to know how many possible combinations I can make up. So there'd be 12 left out. And on C's, I use both of them. So the 16 factorial goes in the numerator, and both the 12 factorial and the 4 factorial go in the denominator. So I number the 16 down till I'm at 12. Would make more sense. 12's cancel, but I still got to go 4 times 3 times 2 times 1. Okay, so parenthesize that. 16 times 15 times 14 times 13. Close it and divide by 4 by 3 by 2 by 1. Okay, so 1,820. Okay, now if there's 10, we need a group of 3. I want to know all the possible groups of 3 I can make up. So there'd always be 7 left out of the group. So 10 factorial, 7 and 3. So 10's numbered down to 7. The 7's cancel, and then 3 times 2 times 1. Okay, so I've got the product of 10, 9, and 8, close it, divided by the product of 3, 2, and 1. Okay, and that's 120. Okay, now we're going to apply this to real life. You have a card sheet, but you won't use that until you actually do cards. Okay, during basketball season, a school plays 12 home games. A teacher wants to attend 3 of those games, so like Newell, Ridgeview, Sioux Central, but I don't need to rank them first, second, third. I just want to go to 3. How many combinations of games can the teacher attend? So I want to write the words have and take from the story problem. So I have 12 games and I take 3, but they're not being ranked, okay? So that's the C. So 12, 3, and 9. So I need to use all these, the 12 factorial, and both the 9 and the 3 need to be there. Okay, so it divides out the ranking of everyone, not just the 9 I don't go to, but also the 3 I do go to, because when you put on bottom, it unranks them. 12 times 11 times 10 times 9. The 9s cancel. 3, 2, 1. Okay, so I take the product of 12, 11, and 10 divided by the product of 3, 2, and 1. Okay, so 220. 220 possible games. Okay, Herbson has 25 people in his math class. He picks 4 of his students to enter a cage fighting free-for-all. How many combinations of students can he pick? So he has 25. He's going to pick 3, but he doesn't care about first, second, third, not ranked. So C, 25, and 3. Okay? All right, so they all have to be in this expression, and then the 22 and the 3. Because when I put these on bottom, it unranks both groups. I don't want anything to be ranked. 25 times 24 times 23 times 22. 22's cancel. And 3 times 2 times 1. So 25, and I always get questions, when do I know when to use the P, when to use the C? Well, I'm going to cover that in the next assignment, okay? 2,300. Okay, now we're going to start playing some cards, okay? By the way, on the assignment, I always get people saying, 25 people in a hoop shoot, the top 5 finishers will have their own tournament. How many combinations of people can be in the top 5 tournament? And they're like, oh, top 5, so you're ranking them. Yeah, you kind of are, but the 5 you pick, you don't care who got first, second, third, fourth, fifth, okay? You just want to find out who can be in the tournament, okay? Just because I say top 5, that doesn't mean I care who got first, second, third, fourth, fifth, okay? Yeah, they did it, but I don't care. I get sick of people arguing with me on that, okay? Because it's not. All right, now let's play some cards. Standard deck has 52 cards. Here they are. You got red, which is hearts and diamonds. There's 26 red cards, and then 13 hearts, 13 diamonds. 26 black cards, clubs and spades, 13 and 13. Now I want to find out how many possible 5-card hands I can be dealt. So I could be dealt the 4, 5, 6, 7, 8 of clubs. That's one hand, okay? I can also be dealt the 4 of clubs, 3 of spades, 2 of diamonds, 3 of diamonds. There's a bunch of them. So I have 52, but we're going to pick 5 at a time, okay? So it's the C, so 25, or 52, sorry. 5, and then 47, okay? So I have 52 factorial, and we're not ranking the 5, so they're not ranked. There's no first, second, third, fourth, fifth to the problem. So I put 47 and 5 down here. So I would number the 52 till I'm at 47, and then the 47s go bye-bye. And then 5, 4, 3, 2, 1. So I wrap that up, put parentheses around. So I have to find the product of 52, 51, 50, 49, 48, parenthesize, unparent, and then divided by parentheses 5, 4, 3, 2, 1. Close it. So 2,598,960. Okay, you're going to want to remember this number here, okay? So you don't have to keep calculating it. So we're going to do some probability with hands of cards. Go. So it says, how many ways are possible to draw 5 hearts? There's 13 hearts in the deck. So with cards, we use the C, because I want 5 of the same thing, so only one C. I want 5 hearts, but we put the 5 here. Now, how many hearts in the deck do we have to pick from? Well, 13. So I want to find out how many of those hands have 5 hearts. So I put 13. So there'd be 8 I wouldn't be able to pick. So I go 13, and then 8 and 5. So I number the 13 down, factor it down till you're at 8. 8's cancel. And then 5, 4, 3, 2, 1. So you can parenthesize those. So parentheses 13 times 12 times 11 times 10 times 9, close it, divided by 5, 4, 3, 2, 1, close it. 1,287 hands can have 5 hearts, okay? Now, to find the probability of it happening, what you do is you take, you know that a whole deck, there are 2,598,960 hands. 1,287 of those hands have 5 hearts. So you divide and times 100. 1,287 divided by 2,598,960, and I times by 100. So that's 0.05. Okay, small chance. And these are like amazing poker hands, so that's why you're going to get small probabilities. Okay, how many possible ways are to draw 4 kings and 1 non-king? Now, 4 of a kind's good, but you're not drawing 4 of the same thing. There's 4 of the same thing, but then there's one that's not like it. So what you're going to need is 2 C's here. So you want 4 kings, so put a 4 and 1 non-king. Now, how many kings are in this deck to pick from? Well, there's 4. So if there's 52 cards, how many are not kings? Well, there'd be 48, because 52 minus 4 is 48. Okay, so there'd be no kings left to pick, and there'd be 47 non-kings left to pick. Now, anytime you see a 0, you don't need to waste your time with the math, because that's 1, okay? Now, this one we probably want to do just to see it. 48, and then 47, and 1. So I go 48 times 47. The 47s cancel, and then it's 1. 48 divided by 1 is 48. Now, you multiply the 2. 1 times 48 is 48. So if there's 48 of the hands that have 4 kings, well, there's 2,598,960 hands. So the probability of that's pretty minuscule. 2,598,960 times 100. 0.002. You have to go to the thousandths place before you actually find something. So that's pretty small odds. You could play cards all day and not get that. Okay, how many ways are possible to draw 2 kings? 2 of a kind's not bad, and 3 non-kings. So I'm drawing cards, but they're not all the same kind like those hearts were. So you need 2 C's, and you want to draw 2 kings, but 3 of them aren't going to be kings. Okay, now, how many kings are in the deck? It says there's 4. And there's 48 non-kings, so I need to find these. There'd be 2 I wouldn't have drawn, and 45 non-kings left in the deck. Okay, so 4 factorial, and then 2 and 2. So I'd number the 4 down till I'm at 2. The 2's cancel, and then 2 times 1. You should be able to do that in your head. It's 12 divided by 2. That's 6. Okay, I'm going to underline that. And over here, probably won't be able to do this in your head. We'll number the 48 till we're at 45 would be smart. Always number down to the bigger number to save. I don't know how to count apparently. The 45s cancel, and then 3, 2, 1. So parenthesize those. And I find the product of 48 times 47 times 46, close it, divide by 3 by 2 by 1. So 17,296 hands have 3 non-kings. 6 hands could have 2 kings. So now I multiply them. 6 times 17,296 is 103,776. So you do 2 problems kind of separately and then multiply your answers. So that's how many hands can have 2 kings. It's a lot more than 4 kings because 2 kings are more common than 4. Okay. So there's 2,598,960 cards in a deck, and 103,776 have 2 kings. So 103,776 divided by 2598960. Then I will times by 100. Okay, that's higher odds. I actually have a whole percent, so it's about 4%. Not likely still, but much higher than those other ones. Okay, now this one's kind of weird. Don't get freaked out by this. On the assignment part, you have 1 card problem to do. You want 3 jacks, 3 of a kind. So C, C, and then you'd have 3, 2, and then 4 and 48. You'd find those. Okay, now this is kind of for card players. If you're not really much of a card player, you might want to just go work on the assignment. How many ways are possible to draw a flush? That means 5 cards of the same suit, like hearts, diamonds, or spades. There's 13 of a suit, okay? All right, now this requires a little bit of outside the box thinking. So let's find all the hands that have 5 hearts, okay? So C, now if we're talking 5 hearts, 5, and there's 13 hearts in the deck. Now I just had this problem, and I got 1,287. So I'm not going to repeat it, because it ain't going to change. But there's 4 suits. You could also do that with diamonds, clubs, and spades. So we could multiply it by 4. That's 5,148. So there's 2,598,960 poker hands, and 5,148 will contain all cards of the same suit, be it hearts, diamonds, clubs, or spades. Times 100. Okay, so 0.2. Okay. All right, that's really all I have to say on that. I hope it's been informative, and I will talk to you guys next video.